Yes, so next, volcanoes. Yes. A crack opening or vent. Okay. Crack opening or vent through which liquids, gases and solids comes out is called as volcano. Right. So a crack opening or vent through which liquids, gases and solids comes out is called as volcano. Now, when I say liquids, we are talking about lava. This lava is divided on the basis of silica content. Okay. Lava is divided on the basis of silica content. If silica content is more, we call it as acidic lava. If it is less, we call it as basic lava. Silica is more, silica is less. Now, if at all silica is more, viscosity is high. If silica is less, viscosity is low. If viscosity is high, you normally form cone shape. If viscosity is low, it normally forms flood basalt. That means plateau. This will be normally in dark color and this will be normally in light color. Acidic is associated with convergent boundary. Basic is associated with divergent boundaries. This is with respect to liquids that come out. Okay. Then, if we consider gases, gases that normally comes out is water vapor, sulfur dioxide, carbon dioxide, methane, ammonia, etc. These are all the gases which are normally ejected. Solids which normally comes out is dust particles and tephra, TEPHRA, dust particles and tephra. Fine. So this is liquids, gases and solids. Structures formed from the volcano. In case the volcano is in cone shape, we call it as basalt cone. If it is spread, it is flood basalt. If ash is accumulated, ash cone. Alternatively, ash and lava is present. Okay. Alternatively, ash and lava is present. Then this particular one is called stratovolcano. Okay, so this is structures associated. Next, shall I move? You will also have some features of the volcano. The first feature is crater. Funnel shaped opening is called as a crater. Caldera. Caldera is joining of craters. If all the craters join, it is called caldera. Whenever the lava solidifies near the opening, solidification near opening is called plug domes. Crater, caldera, plug dome. Ash showers. Ash showers are pyroclastic or dust particles, materials ejected. Yes. Which of the following features are associated with volcanoes? Words are important. Crater, caldera, plug dome, ash showers. You will also have mud flow. Ash plus water. Ejection of sulfur dioxide as sulfotras. You will also have hot springs and geysers. Fine. These are all associated with volcanoes. Next. Earthquakes. Yes. The point where the energy is released is focus. Whenever it is deeper, we call deep focused earthquakes. If it is near, we call shallow focused earthquakes. Okay? Deep focused has less impact as it is far from the surface. Shallow focus has more impact as it is closer to the surface. Deep focus is associated with convergent boundaries. Shallow is mostly associated with divergent boundaries. The point where it first comes to the surface is epicenter. Now, there will be waves from focus to epicenter. Waves are present from focus to epicenter. Words are important. These are called as body waves. From epicenter outwards is known as surface waves. From epicenter outwards is called as what? Surface waves. You see, from focus to epicenter is called body waves. From epicenter outwards is called surface waves. Okay, shall I move? Whose impact is more? Surface waves are more impact, and the impact of surface waves reduces outwards. Fine. Next. Now, body waves, if we take, they are divided into two. Body waves are divided into two. It is P waves and S waves. P waves are also called as primary waves, and they are called as longitudinal waves. P waves are called as primary waves or longitudinal waves. Yes, there will be compression, rarefaction, compression, rarefaction, compression, rarefaction. So, what are the two words here? Compression and rarefaction. These two are present. And we also say, if particle is moving like this, particle vibrate parallel to wave direction. Particle vibrate parallel to wave direction. Next. They are similar to sound waves. This point is very important. Particle vibrate parallel to wave direction. P waves can travel in solids, liquids. And at last, density is more, speed is more. Density is more, speed is more. All these are with respect to P waves. S waves, they are known as secondary transverse waves. They move in the form of crests and troughs. Particles vibrate, very important, perpendicular to wave direction. They are similar to ripples in water. Travel only in solids. Again, density is more, speed is more. Common property of P and S wave is if density is more, speed is more. Both travel in solids, but both S do not travel in liquids. Next, if we take surface waves, we have two types. Rayleigh waves, where particle movement is elliptical. It is R waves. Love waves, zigzag. It is more destructive. These are surface waves. Now, shall I move? P waves Which waves are we talking? P waves. Okay. S wave shadow zone is more compared to P waves. What is the reason? S waves do not travel through liquids. Okay. Just 2 lines below this. Shadow zones have curved path, curved, curved path, indicating that density is not uniform. That density is not uniform inside the earth. Not uniform inside the earth. Next. P wave shadow zone is less compared to S waves, because S do not travel in liquids. Okay. Shadow zone is because of refraction. So what is happening? Bending occurs. If bending doesn't occur, it will go straight. Because of the bending, shadow zone comes. That is refraction. Okay, that is responsible. Now, yes, this interior of the earth. Interior of the earth. Direct evidences. Indirect evidences. Direct evidences are mining, volcanoes. Indirect evidences are meteor burning, yes, gravitational force. Can we say gravitational force is maximum near poles and minimum near equator? It is also due to geomagnetic field. Can we say geomagnetic field help us in understanding that, like, inside there is a liquid layer? Okay. At last, it is also due to what? Seismic waves. Okay, direct, indirect evidence. Now, 0 to 35, 0 to 5. Continent, ocean. Hundred. What will you have? Upper solid mantle. These two together is called as lithosphere. Till 600 kilometers, it is called asthenosphere. Asthenosphere is semi-solid layer. Asthenosphere. Till 2900 kilometer, it is lower solid mantle. This particular part is called pyrosphere or mesosphere. Okay, till 5100 outer core, inner core. Barysphere. In between crust and mantle, there is moho discontinuity. Mantle and core, there is Gutenberg discontinuity. Mantle and core, we have Gutenberg discontinuity. Outer core and inner core. Lehman discontinuity. Crust and upper mantle and lower mantle. Repeti discontinuity. Upper crust and lower crust. Conrad discontinuity. You have to remember these. Done? Shall I move? Next, rocks, primary, parent, or igneous rock. Formed from fire or lava, so it is volcanic rock. Fossils are absent. Layers are absent. You will not have stratification. It is formed due to process, heating, melting, crystallization. Okay, there will be melting and crystallization. 3. Shall I move? Next, igneous rock is divided on the basis of where it is formed. It can be intrusive igneous rock. Example is granite. Very, very important. Granite is an example of intrusive. As it is intrusive, cooling takes time. Cooling takes time. So we normally observe coarse grains. Lumps will be formed. Coarse grains. Now, this intrusive igneous rock is divided based on the shape. If it is present deep inside, what do you call it as? Batholith. You recollect batholith is what? Deep inside. Deep inside is also called plutonic rocks. Okay, plutonic is also deep inside. Sills and sheets are horizontal. Sills and sheets are horizontal. Dike is vertical. Dike is vertical. Laccolith, which shape? Mushroom shape. Lopolith. Good. saucer shape, wavy shape. Extrusive igneous rock, fine grain. Example is basalt. It is divided into acidic rocks, basic rocks, ultra basic rocks. Acidic, basic, ultra basic, based on silica content. Okay. Next. Sedimentary rocks. It is derived from the word sedimentum, which means settling down. Most important phenomena is layers are formed. As layers are formed, fossils are present. These rocks are mostly in the form of folds and faults. Layer by layer accumulates here, folds and faults. Divided into two. Clastic sedimentary rocks. See guys, somewhere there will be erosion. After erosion, there will be transportation. Once it is transported, there will be sedimentation, deposition. After sedimentation, layer by layer accumulates. It's called compaction. As pressure increases, salt particles will bring them together, called cementation. Yeah. Rocks are broken, those small particles are brought and they are transported. They are deposited in the water bodies called sedimentation. After that, compression will occur. Layer by layer gets accumulated. That is called compaction. And then salt particles will join them together, called as cementation. Okay, so here sand will form stone, called as sandstone. Clay will form stone, called as claystone. Mud will form stone, called as mudstone. Okay, and then you will also have shale. Second type is chemically precipitated rocks. Okay, imagine salt water is there, salt water is evaporated, salts are left behind, the salts become solid to form rocks. Okay, salt water evaporates to form rocks. Limestone, dolomite, chert, evaporate. Okay, these are all what we call as sedimentary rocks. This is very important. They had asked question, what is evaporite? It's a type of sedimentary rock. Then metamorphic rock, which means change in form. Change in form. The change in form is due to heat or it is due to pressure. If it is due to heat, it is called as contact metamorphism. If it is due to pressure, it is dynamic metamorphism. Okay, one is contact metamorphism, another one is dynamic metamorphism. Heat and pressure. Marble is an example. Schist, slate are examples of metamorphic rocks. Fine. Next. Endogenetic process based on time, it is divided into diastrophic process, which means slow process. It can be catastrophic process, which is sudden. Diastrophic is slow, catastrophic is sudden. Earthquakes, landslides, volcanoes are catastrophic. This slow process is further divided into two. What are the two terms? A pyrogenic, orogenic. Okay. A pyrogenic normally means vertical movement. Okay. A pyrogenic means vertical movement. Vertical movement normally leads to submergence, emergence. Submergence Konkan coast in India, submergence. Emergence, which coast will be there? Gujarat coast, Malabar coast, East coast comes under this, a pyrogenic. Orogenic is mostly horizontal movement. There are two types: folds and faults. Okay, this is endogenetic process. Next, shall I? Only words you just look at it. Don't go beyond that. Words are enough. Exogenetic process. Weathering. Because weathering means breakdown of rocks in situ. Okay, this is further divided into physical weathering, chemical weathering, biological weathering. Second is mass movement. Mass movement means transportation of material. Why is there transportation of material? Transportation of material due to gravity. This is important. It is not moving due to anything. It is due to gravity. So you will have fall or flow, which is normally fast. Fall or flow is fast. Slide. Then you will have creep or heave. Creep or heave is slow. Okay, this will be fast, this will be slow. Slide will be in between. We have three words: fall, slide, creep. Okay, this last is erosion. In erosion, you will have breakdown plus transportation plus deposition. So I'll have three things: breakdown, transportation, deposition. So when you have all the three, okay, when you have all the three normally, like all the three normally leads to two things. It will lead to erosional landforms depositional landforms. So you'll have erosional and depositional landforms. This is with respect to exogenetic. Questions are not there from last 10-15 years on this. So just I want you to read what are all the erosional landforms. For example, you take rivers. If you take rivers, erosional landform will be like valleys, waterfalls, okay? And then you talk about plunge pools, rapids. These are all examples of erosion. You will have deposition, deltas, estuaries and all. So if you can just work on that, that's enough. Don't waste your time in details. Yeah, this was not in UPSC. Other exams they have asked. CAPF exam. I'll just give this. These are not required. This I'll give. Physical weathering. This year CAPF exam had this. This we say freeze thaw weathering. Okay. This what is physical weathering? It is breakdown, and they use a word called disintegration. Okay. Disintegration. Everything is coming out. In that first one is freeze thaw, or we call frost shattering. Is water ice. Alternatively, when it forms, it will break. Second, we say insolation weathering. That means in arid and semi-arid region, because of high temperature, there will be weathering called as insolation weathering. Insolation weathering. Yes. Sometimes when suddenly pressure is removed, there will be expansion due to unloading. Sudden expansion due to unloading. That is also physical weathering. Okay. This layer by layer will be removed. So it is called as exfoliation. All this is right. Everyone understands. But the last one, this is important, guys. This was asked. Salt crystal growth. Okay. Everyone listen. What is salt crystal growth? In coastal areas, salt water accumulates in the rocks. Water gets evaporated. Salts are left behind. That salts expand and contract alternatively, and rock break. Okay. Now, the rock is not breaking because of change in composition, but the rock is breaking because of expansion. So, the moment we see the word salt, we think it is chemical weathering. But salt crystal growth is typical example of physical weathering. So, what is the difference between physical and chemical? If there is change in composition, we call it as chemical weathering. If there is no change in composition, we call it as what? Physical weathering. So that's why that word is very, very essential for you. Which word? Which word? Salt crystal growth is a type of physical weathering. Many people get confused. That's why this was asked in the exam. Okay. Then you have chemical weathering. Guys, chemical weathering will have oxidation, which is an example of rust. Oxidation, which is an example of rust. Carbonation. Carbonation, where carbon dioxide reacts. Solution, where acid rain reacts. Solution, acid rain reacts. Hydrolysis, water tries to remove certain particles. These are all what? Chemical. Biological, living organisms is involved. Okay, these words, guys, nothing more. This is bottom topography, right? All the layers. Okay, I'll tell the words, you just write them. Continental shelf. Continental shelf. Hyphen. Gentle slope. This word is important. First, gentle slope. Second, shallow waters. Shallow waters. Okay. Third, sun's rays penetrates. Sun's rays penetrates. You tell me, if sun's rays penetrates, can we say that photosynthesis occur? Yes, you're right. Sun's rays penetrates, photosynthesis occur. Photosynthesis occur. Now you tell me photosynthesis is present. Can we say fishes will be there? Yes, you're right. Hyphen fishing. Fishing. Example. Dogger Bank. Dogger. Dogger Bank in North Sea. Okay, Europe. Dogger Bank in North Sea. You recollect Grand Banks between Gulf Stream and Labrador? This is Dogger Bank. Okay, North Sea region. Next, you're right. It is formed due to submergence. Whenever land goes down, continental shelf will be formed. It is formed due to submergence. Submergence. Or formed due to submergence, or due to deposition. Or due to deposition. Next. It is almost absent near Chile. Almost absent near Chile. Next. It is very huge near Siberia. Huge near Siberia. Next, continental slope. Continental slope. Steep slope, less species. Next, continental rise. Continental rise. Hyphen. Present only in stable boundaries. Present only in stable boundaries. And are absent. When trenches are present. When trenches are present. Next, submarine canyons. SUBMARINE. Submarine canyons. CANYONS. Submarine canyons. Hyphen. Present in continental slope. Present in continental slope. Next point. Abyssal plains. Abyssal plains. Hyphen. Part of oceanic crust. Part of oceanic crust filled with sediments. Filled with sediments. Next, it is flat in between. Flat in between continent and island. Continent and island. Next, thickness of sediments. Thickness of sediments will depend upon. Thickness of sediments will depend upon age of the crust. Age of the crust and presence of trenches. And presence of trenches. Are you getting the point? In Pacific Ocean, it is less because trenches are more. Trenches are more. Next point. Islands and ridges. Islands and ridges they are formed in convergent and divergent boundary. They are formed in convergent and divergent boundary. Next, trenches. Deepest part of the oceans. Deepest part of the oceans present only in convergent boundary. Next, seamount and Guyot. Isolated mountains are seamount, and flat topped seamount is Guyot. Done. Salinity. So we call something to be fresh water if it is 0 to 5 parts per thousand. We call it brackish water if it is 5 to 30 parts per thousand. Okay. We call it saline water if it is 30 to 35 parts per thousand. It is called as brine water greater than 35 parts per thousand. Okay. This is with respect to salinity. Which one? In oceans, yes. Pacific Ocean is convergent boundary. Okay. Pacific Ocean, you have only East Pacific rise which are divergent boundary. Mid-oceanic ridges is divergent boundary. Okay. So ridges, if they are present in almost, as I told you, it is present in Atlantic, Pacific, right? There, these are all what? Divergent ridges. Pacific Ocean, especially China, Japan, this area, it is convergent. Pacific Ring of Fire region. Okay. So, guys, factors you tell, very important. See, guys, more evaporation is more. What happens to salinity? Increases. Rainfall is more. Decreases. Wherever rivers flow, salinity decreases. Onshore wind, that is sea to land, salinity decreases. Okay, when it comes from sea to land, it deposits salts into the land. Offshore winds, increases because they add sediments into the water. condensation, that is formation of glaciers. Glacier formation. In remaining water, salinity increases. Okay, not in the glacier, in the remaining water, salinity increases. Last, ocean circulation. This helps in movement of salinity from one to another. These are all the factors of salinity. Okay, so tomorrow we'll start with, see, I have to talk about resources, marine resources, tides little bit, I'll tell, tides and tsunami, and then we'll discuss about Indian space. Just bring atlas, we'll be seeing them. Fine? Okay.